Thanks everyone for dialing in today, and let's get started. How to find lateral movement with Zeek and MITRE ATT&CK. Next slide. Vince, maybe you could give people a sense of your background.
Sure. Hi, everyone. Thanks for joining. My name is Vince Stouffer. I'm on the product management team at Corelight, a longtime Zeek user and security engineer, and excited to talk to you a little more today about how we can use Zeek to show lateral movement on your network.
Thanks, Vince. And as I mentioned earlier, John Gamble here, Director of Product Marketing at Corelight. I've been with Corelight 3 years now, and I've spent my career representing products in the data protection space across privacy, security, identity verification products, and I've really spent the last 8 years in cybersecurity. And like Vince, I'm also excited to show you guys some stuff that open source Zeek and Zeek logs can do for you in terms of revealing lateral movement activity in your environment. Next slide. So we're going to try to keep this tight. If you're like us, you've probably spent way too much time on Zoom and GoToMeeting these days with everybody working remotely. So we're not going to take a full hour. We're going to try to keep this thing under 30 minutes. We'll first kind of baseline knowledge around the MITRE ATT&CK framework, just to make sure everyone on the call understands what that is. Then we'll take a look at open source Zeek and its functionality, so you have the context for when we actually look at some of the data. We'll briefly touch on Corelight. Who are we? Why are we presenting this material? And we'll close really on the heart of this presentation today and show you some examples of where you can take that Zeek data and some of the Zeek capabilities within the Zeek framework to actually find lateral movement activity inside your own environment. And we'll save a few minutes at the end, hopefully 2 or 3 minutes at least, maybe 5 for Q&A if we have time. Feel free to ask a question at any point. Just type that into the question box. We'll see it. We're going to save questions until the end. And lastly, we are recording today's webcast. So if you'd like a copy of the recording to watch later or share with colleagues, that will be provided to you as well. So don't worry, we are recording and we will make it available later. So with that, let's head to the next slide, MITRE ATT&CK. So the MITRE ATT&CK framework, you've probably heard of it. Many of you are probably actively using it. But in case this is something you haven't really engaged with, let's just kind of baseline quickly what we're seeing. So Vince, maybe you could just click through the next couple builds. So there's a couple different matrices. MITRE is an organization that does a lot of things around security, and one of the key things that it does is it sets these kind of matrices that document adversarial behavior, observed real-world observations of adversarial behavior, organized along adversarial tactics and techniques. And there's different matrices for different kind of attack spaces. There's one for Windows. They actually have a mobile matrix that describes attack techniques for mobile endpoint devices. But the matrix that we're going to focus on today and dig deep on lateral movement is actually the enterprise matrix here that you see. And if you go left to right, as you see in that blue arrow here, it's actually kind of describing the chronology of the attack. So those things that you see in the columns, the titles there, are ordered in approximate kind of chronological order of what you would actually see during the attack stage. So it starts, of course, with initial access there on the left-hand side, where they're just grabbing kind of those initial footholds in your environment, whether that's stolen credentials or phishing right through email to get those credentials. And then as you move to the right and you get towards the end, you get to the stage of the attack where they're actually stealing and exfiltrating data out of your environment to servers and databases that they control. Endpoint technology tends to be more favorable to the first kind of half of this chronology that you're looking at. And if you click again, Vince, the network kind of technology and detection side of this tends to be more favorable on the latter half, right? The point where they've already got inside your systems and they're moving about, and you really need that kind of holistic visibility in your environment to understand what's happening between endpoints, between servers. It's those communications at that stage that you're really interested in catching. It doesn't mean that endpoint technology or network technology can't kind of help you on either side of the spectrum. We're just pointing out here that this is where those technologies tend to be favorable. So today we're going deep on lateral movement, and we're going to look at how Zeek, which is this great open source tool, can help you there. So the next slide, Vince. Lateral movement, again, this is kind of that second half of the chronology. This is where they're inside your environment. They've breached the perimeter, they've gotten in, and they've gotten a foothold, and now they're moving within your organization, right? Between servers, between systems that don't necessarily talk out to the public internet, right? So these movements that you're looking for may not be observable over the perimeter of your network. In fact, many of these movements are between things that don't touch the public infrastructure. So you're looking for things like SMB movement, right, is something. Sometimes it does, right? SSH hijacking, which we call out here as an example of a lateral movement technique that MITRE documents. That's someone SSHing into your environment from an external endpoint into your environment. So again, it doesn't necessarily mean that they're not crossing the perimeter, but thematically, what we're looking for here is often things that are not crossing the perimeter. Although SSH hijacking is an example there where that's not the case. If we go to the next slide, Vince. So, how are we going to find this kind of behavior in the wild? Whether that's somebody abusing, SMB traffic or hijacking SSH? Well, kind of at a high level, two strategies, right? We could detect it, right, with some sort of heuristic, some sort of logic or signature or model that looks for that sort of behavior and surfaces an alert. On the other hand, we could also use data to go find or hunt for that activity proactively. As human analysts, if we know what to look for and we have the right evidence to look for that kind of behavior, we can actually go find it live in our environment. Or if we have historical records, we can retroactively find evidence of that occurring in the past. And again, this tends to be a more network data favorable exercise. You can certainly look for evidence of lateral movement with endpoint kind of telemetry. And in many cases, that's a great strategy. But it tends to favor the network here because, again, it's all about movement between systems, right? So you may not have perfect endpoint coverage and telemetry from your various systems, services, and endpoints in your environment, and they're moving between these things. And so you actually want the context of that movement, which is communication, which is network. So what data, what network data specifically, can you go to for that kind of insight? Vince, I think the next section, you'll tell us a bit more about Zeek. Oh, sorry, one last slide here before we flip over to Zeek. So, the data that you might be using today to look for this kind of lateral movement behavior, if you have it, could come from a variety of kind of physical network infrastructure and the logs generated therein from those pieces of equipment in your environment, right? You've got a whole range of appliances or network services that are generating metadata and logs about your environment. But the challenge here, and if you click next build, the challenge here is that most of these data sources weren't designed for security use cases. In many cases, they were designed for IT use cases, right? Troubleshooting, performance optimization, debugging, tuning these physical appliances that are in your environment that are delivering network services. They weren't really, most of them by and large, designed for security analysts to use to find bad actors or malicious or anomalous activity. And so it can be very, very frustrating as an analyst sitting there trying to basically cram and correlate disparate data sources into a uniform data format, right? Timestamps may not be aligned between your servers, between your Windows logs, for example, and some of your DNS servers. Those timestamps may differ. That's going to cause a pain when you're trying to connect the dots between those two sources. So, I call it a bad puzzle game that a lot of analysts play, not because they want to, but because they kind of have to. They're forced to. That's the data that's available to them. They beg and borrow for access to this data from the IT team in many cases because the IT team doesn't always want to enable access to this data or even turn on logging in that case because it can degrade the performance of these devices. So, you can certainly go to some of these data sources to look for lateral movement, and you can find lateral movement with some of these data sources, but it's not an easy task and can be quite frustrating, which is where Zeek comes in. So Vince, maybe you could tell us a bit more about the open source Zeek platform.
Absolutely. So many of you are probably familiar with open source Zeek or have heard of it or are active users of it. But let me just give a little bit overview so everyone understands exactly what it is and we're all on the same page. Open source Zeek is a open source network monitoring framework or project that has been around for almost 25 years. It has really began in kind of the research and education space, and over time has now been adopted by pretty much all of the major enterprises around the globe as the standard for network traffic analysis and in many cases for detection and aiding with response as well. So at the we know that Zeek is used, and you may have been exposed to it in SANS training courses or Cisco certifications. It's broadly used across network training, and part of what is really powerful about Zeek and a few things we're going to share today is just around the community that exists since it's an open source project. So there are hundreds of different Zeek packages or scripts out in the world, and that is that list is always growing. And we're going to give a couple examples of what those scripts are like today. But maybe first, let me say that, you know, fundamentally, Zeek has kind of these three aspects to it. It takes in raw network traffic in all of its complexity, and it transforms it into events. And from those events come out logs, which are the Zeek logs, or formerly bro logs that people always refer to, right? These are protocol specific logs relating to what's happening on the network as it's being monitored. Zeek also has the capability to extract files or carve files directly off the wire. So you can write those into file storage and put them through static or dynamic analysis for your investigations. And of course, the scripts or packages I'm referring to come from using Zeek's domain-specific scripting language, which allows you to stitch those events that you're taking off of the wire into a full programming language to do almost anything that you want. And so many times the packages that are developed with Zeek are not using signature-based approaches. These are usually behavioral-based approaches. So if this sequence of events occurs in a particular way, generate an alert or take an action, rather than if I see this particular IP address on the network, take an action, right? Which is much more a signature-based approach. And so because of the way that those behavioral packages operate, they're much more durable and also much more adaptable to the kind of highly technical use cases for something like lateral movement, where you really need to see a series of actions to be able to piece together, you know, malicious intent rather than just normal operations. So Zeek's normally deployed, you know, it's always deployed out of band, right? It's not an inline tool, so it's always deployed on either an optical tap, a span port, or some sort of packet broker to deliver raw network traffic into Zeek. It does its processing, generates the logs, the insights, the extracted files, etc. And you can also enhance it by adding a whole bunch of different external data. So intel and you know, information around what you have in your asset inventory, et cetera, can be rolled into Zeek in some of its various frameworks. So you can provide a lot of context around what's being seen on the wire directly by using some of Zeek's additional capabilities, which is pretty powerful. And of course, once you have those logs and those extracted files, those often get passed off into some sort of other system for further analysis or analytics, and that could be your SIM, it could be you know, a complicated you know, ML pipeline. It could just be the command line where you're using grep and awk to search through those logs directly. So there's a lot of power in having the best network data at your fingertips and a lot of different ways to use it. And so what makes Zeek logs special? Well, John kind of touched on this, right? The power is in the connectivity of the data. So for each connection, you're going to have a record of what happened, which is kind of like NetFlow on steroids, right? It's got all the information about the connection, and then the additional protocols that are being used all show up in separate logs, and those are all linked together with a unique identifier. And so it's easy to sort through and search and find all the information about a particular connection. At the same time, getting extremely detailed low-level information about what's in each of those protocols. So for example, here is a DNS log for Zeek, and then maybe a typical what you might see in a DNS query log for Bind or Microsoft DNS on the bottom. And so what you see is just a tremendous amount of more information. You have all the different flags that were used for the query. You have the actual response from the server, so you're seeing not just the query but the response and everything that you'd want to see. So when you're either responding to an incident or doing a threat hunt, having that level of information and being able to then program against it is amazingly powerful. So that's a quick intro to Zeek. There's lots more to learn. Of course, you can go to zeek.org to learn more. John, I'll hand it over to you to tell a little bit more about Corelight. Oh, John, are you still there?
I am, sorry, I was on mute. Let me come off mute. Yeah, thank you, Vince. So real quick, just a word from today's sponsor, Corelight. Who are we? We are the makers of an open NDR, and that's network detection and response platform comprised of two powerful and widely used open source technologies, Zeek, which you just heard Vince describe and give a good overview of, and Suricata, a powerful open source IDS technology. And so kind of where we sit, right, in your architecture is feeding Corelight sensors traffic, whether that's a packet broker in a physical networked environment or in the cloud using a native cloud tap, basically feeding those raw packets off the wire to Corelight drives this transformation of that raw packet material into the logs, into the file extraction, and the scripted events that Vince just mentioned in his Zeek overview, as well as signature-driven alerts from Suricata if customers are running that as well. And ultimately, our customers are putting that information typically in a SIM like Splunk or Elastic or a SIM of their choice. And that's where the analysts are kind of consuming the evidence and the insight that the Corelight platform generates. And if you click once more, Vince, how do we deliver that? Through a range of different format sensors. So whatever kind of, wherever your network traffic goes, we aim to be there. We make sensors for cloud environments, AWS, Azure, and GCP. We have a virtual sensor format you can run in VMware or Hyper-V. We have a new sensor actually that we just released that's a binary that you can run flexibly in Linux environments and in containerized environments as well. So it's a very lightweight sensor deployment option. And we have a range of physical appliances with varying kind of throughput speeds to support your kind of core networks and fleet management capabilities on top of all of those. So in a word, who is Corelight? We make this great platform that gives you, direct access to evidence and insight on your environment. And we make these really great open source technologies even better. Easy to deploy, super fast, super reliable, easy to manage, and already pre-integrated with all of your favorite tools. So if you're interested in using Zeek or Suricata, come talk to us because we've got some great products there. All right, that advert's done. Let's go back. Let's put 2 and 2 together. So MITRE ATT&CK, right? Zeek. Let's put 2 and 2 together and look at some specific examples of where this evidence and insight that Zeek is capable of generating can actually be used to find lateral movement in your environment. Next slide. All right, so let's look at a specific TTP, T1570. So I didn't mention this in my MITRE ATT&CK overview, but if you're not familiar, all the techniques in the MITRE ATT&CK framework are numbered and organized according kind of to their overall kind of categorization. In this case, of course, we're talking about lateral movement. So within lateral movement, a specific technique is lateral tool transfer, which is where adversaries are now abusing your internal kind of systems and communications to move tools, files, something that they need between systems to enable the next phase of their attack. So that may be an exploit kit that they're trying to get into a protected part of your environment. That could be kind of a backdoor that they need to be able to communicate back out to C2 servers. There's a variety, and I don't have to illustrate here. There's a range of possibilities that are bad, where they're now transferring software within your environment to further enable their attack sequence. And in particular, we're going to look at SMB traffic in this particular example here to look for evidence of lateral tool transfer, because SMB is, in many organizations, a widely used protocol. So it can be quite noisy. There's lots of records and lots of communications happening. But it's a Windows machine protocol, widely used, of course, for things like file transfers and printer infrastructure and serial port sharing, et cetera. But it's a great place to hide, but it's also a great place to transfer information inside your network. And so the relevant Zeek logs related to this example are the SMB files log and the SMB mapping log. And if we click to the next slide, we're going to talk about MITRE BZAR, which I think Vince kind of briefly mentioned in his Zeek section, but let's actually go deeper here. So there's 3 kind of core capabilities of Zeek, right, that Vince covered: logging, file extraction, and scripting. Zeek is a Turing complete programming kind of language. So you can create programs or scripts using that to detect behavioral, activity, to detect specific, signatures, a whole range of things. Really, your imagination is the limit because, again, it's a programming language. And so the community has taken that power over the last decade plus and developed these hundreds of scripts that Vince alluded to. One of these scripts is called MITRE BZAR, BZAR. And it was developed initially by a gentleman named Mark Fernandez, who works at the MITRE organization. So he actually kind of works inside the MITRE organization in addition to contributing to the open source Zeek development. And he's since had help from the community. And so you can see there in the lower right-hand corner of that GitHub screenshot that there's now additional contributors that have helped to improve upon his initial work as he continues to develop it. And it's the bro/Zeek attack-based analytics and reporting, nicely truncated BZAR. And it does a lot of things. It's a Zeek script. It's a Zeek packet. It's a series of scripts in a Zeek package that detect a number of different attack techniques in the MITRE ATT&CK framework, which include lateral movement techniques. And among those techniques that it can detect are lateral tool transfer. And I put links here. If you're curious, you can go right to GitHub there and download it and run the package yourself in a lab or in a production network. And if you're interested in more information, I've also linked there to a YouTube video where Mark and his colleague John Wunder go through this package in detail and show kind of how you can use its various outputs in hunting activities. A copy of this deck will be made available as well, so don't worry about writing down that URL, or you can just hop on YouTube and Google it and you'd find it quickly as well, but we will also provide a copy of the deck, so don't worry about that. But I want to, if you go to the next slide, Vince, I want to kind of double click, right? So among the various techniques that this BZAR package can surface are lateral tool transfer, instances of what it believes to be lateral tool transfer. And at a high level, without going into the particulars, it's kind of looking for kind of anomalous attacker-like behavior around transfers of tools within the SMB framework here. And it's surfacing a Zeek notice, which is a special kind of Zeek log when it finds that activity in the environment. And I'll also note, and the authors of MITRE BZAR also note in their documentation that MITRE BZAR does require some tuning. It's not something that you would necessarily want to deploy without tuning at scale in a large production environment. It requires some tuning because, of course, every network and environment can be quite different. But once it's properly tuned, that's what it's going to surface, and it will create a new Zeek log that will say, hey, based on our analysis of this SMB traffic and the logic kind of behind this, we believe that this represents an anonymous kind of SMB activity and may be an indicator of lateral tool transfer. So that's actually surfaced automatically as a Zeek notice log, which is, you can kind of think about it like a Zeek alert in your SIM. Not only does it do that, but the BZAR package is kind of multifaceted, right? Not only does it detect a number of techniques like lateral tool transfer, but it also takes advantage of Zeek's file extraction capabilities, right? One of the 3 core kind of functionalities that Zeek offers. And so when this kind of a notice about believed lateral tool transfer occurs, it can actually pull the piece of software that's being moved and download a copy of that, extract and reassemble that particular file for forensic analysis. So you could put that into a sandbox. You could run that, hash it and run it against VirusTotal. You could send it to a dedicated file analysis platform like FireEye. There's a range of things you could do. But what I love about this example is it's the trifecta, right, of Zeek. MITRE BZAR does everything that Zeek is capable of at its core. It's a package, so it takes advantage of Zeek's kind of open scripting nature. So these things are actually scripted using the Zeek framework. It uses Zeek's logs as the basis for the logic that runs on top of it to look for evidence of this lateral tool transfer. And, the trifecta, it can extract the actual software itself that it sees being moved through Zeek's file extraction framework. And so it's just a really wonderful example of the community. Mark Fernandez and the folks that have co-developed this with him, taking full advantage of Zeek's capabilities to deliver insight. And it continues to grow and they continue to iterate. I believe I was checking the GitHub and they've most recently updated this in October. So they continue to develop on this package. So I'm going to turn it over to Vince now to provide one more example.
Sure, sounds good. So taking another example of a community package, which is pretty cool. Here we're going to talk about exploitation of remote services. And so this is really just an attacker, again, inside your network, now leveraging already existing services and compromising them with either well-known vulnerabilities or something new and novel. And so the example we're going to take here is actually the Eternal Blue, or the Eternal class of exploits. These were famously used in the WannaCry and NotPetya malware, but have also been out there in the wild since the NSA kind of uncovered them and have caused over $1 billion of damage in just the first year alone. And so these exploits are focused around the Windows SMB1 protocol, which is quite vulnerable, but still widely used, especially with legacy versions of Windows that are out there. And so there's been a Zeek package contest. There's actually one just finishing right now, the third iteration of this. But for the first package contest that happened, a person, Lexi Brent, wrote this package called Eternal Safety, which actually looks for the particular exploits that this Eternal class of attacks uses and identifies them using Zeek. So basically, we'll walk through a quick demo, like using Metasploit. We're going to load up the Eternal Blue exploit here. We're going to set our remote host and exploit it. You can see there on port 4444, and that's the actual shell coming back. And here we are looking at Splunk and a notice log, as John was talking about, an alert from Zeek highlighting that Eternal Safety has found something unusual. So it's triggering. Interesting kind of side note here is a second notice that I'm showing on the screen now is actually from MITRE BZAR. So to connect back to that, we have two different packages able to identify a similar type of attack using different techniques. In the case of Eternal Safety, it's actually looking for a set of behaviors. And in the case of MITRE BZAR, it's looking using its normal framework to collect those indicators together and then generate specific notices around some of the mechanisms that are being used. So in this case, this is the remote service control manager, I believe, and it's creating a new service. And so you can see it's marked as an attack execution, and it's giving the same information that we had related to this attack coming from Eternal Safety. The difference with Eternal Safety is it's not looking for any particular signature, right? This is really going after, again, the behavior of some of the way that these Eternal class attacks are used. So sending particularly crafted packets to these services to overflow them or exploit them, and then execute arbitrary code. And so what's pretty neat about Eternal Safety is it finds Eternal Blue, it finds several of the other Eternal class exploits that are already out there in the wild, and it has the capability to find yet undiscovered vulnerabilities using that same type of attack. So again, this is the real difference between something like a Suricata or signature-based approach and something like Zeek, where it's able to use a behavioral technique to discover how the attack is working, and then look for any types of attacks that might be exploiting these particular services. And in this case, it's an unimplemented rename command that's sent that triggered the notice. And so no matter what program or logic did that, we'd be able to identify that. So a pretty cool example, again, of using MITRE BZAR, of using the package called Eternal Safety, and using the Zeek events and the logs of SMB, especially in these cases, to look for examples of lateral movement with Zeek. So this is just a quick nutshell of stuff that you can find and how you can use a couple of the open source community packages. There's, of course, a lot more to dig into, but that's all we had time for today. We wanted to keep it short, as John said, about half an hour, and maybe we have time for a couple quick questions. I don't know, John.
Yeah, I think we've got a couple questions here. Maybe I'll pick 2 or 3. We started about 3 minutes after the hour, so we can go 2 more minutes here and keep us to our 30 minutes. Let's see here. Yeah, related to what you were just talking about, Vince, why don't we just jump into that question? Can you talk about the prevalence of SMB v1 traffic in our environment? I think the question's asking, like, how common is that related to that exploit?
Yeah, well, not sure exactly when SMB1 was deprecated, but it still exists out there, certainly for older operating systems like XP and Windows 2000, etc. But often some newer OSs as well will still be able to revert back to SMBv1. So I think it's more common than you'd think, especially when you consider embedded systems and IoT and people bringing their own older devices onto your network. It's not just a matter of if your enterprise is tightly controlled and you're all on the latest versions of the operating system of Windows or whatever you're using, right? It doesn't mean you won't see SMBv1 on your network, and it doesn't mean that it's not exploitable.
Great. All right. I think we've got time maybe for one more question. And if you want to advance to that last slide, I think we've got contact information if people have additional questions. Um, all right, one last question and then we'll call it a wrap. Let's see here. Okay, let's finish on this question here. How do I instrument visibility in my network to see this kind of internal SMB traffic? For example, a firewall isn't going to see this. How do I get this visibility?
Yeah, it's true. Oftentimes Zeek is first deployed at the edge of the network. So you're seeing the border traffic, you're seeing north-south traffic. It can certainly be more challenging to instrument internally, but we also find that customers that are willing to spend a little time to get access to some, particular choke points within the network can really get a whole lot of advantage by looking for this type of attack traffic within their network. And so it's really just a matter of setting up the infrastructure, be it, again, taps or span ports or points of visibility where you can collect a number of your internal subnets and see cross subnet traffic, but maybe not go all the way to the border or through your north-south links. So being able to collect that and harness it and send it into a Zeek server. It doesn't have to be the same server. You could have multiple servers covering, east-west and north-south, which is what some people do. But you do need some instrumentation to be able to see this. But again, I think the big difference is this is probably traffic that you're not covering in any other way, right? A lot of the attack stuff we talked about today isn't available in Windows event logs. It's not necessarily available in EDR, depending on what you're looking for and how the compromise happens. And so being able to have the network view is really critical, and that's what a tool like Zeek can give you.
Great. I think on that note, we'll close. Actually, I'll just tell a very quick story related to that question and your answer, Vince. I remember a Corelight customer told us that they had just put Corelight running Zeek in their environment in, and their boss came to them and said, hey, we have a potentially sensitive issue with an SMB file share and file access. Need you to investigate. Did this happen? If so, needs to be documented. This could be board level problem. And the person said, thank God I had put Zeek into the environment with Corelight, 3 weeks prior, because otherwise he would have been left kind of pouring through thousands of Windows logs trying to find the answer to this particular question that he said he thought the investigation could have easily taken days. Instead, it took him literally a matter of minutes pivoting in his SIM, looking at some of the logs, the SMB logs, to figure out what the answer to that question was, document it, and get to go home at a reasonable hour from his job. So great little story that directly ties to what Vince just said with respect to instrumentation and the visibility. So with that, let's call it a wrap. We more or less kept our promise to a quick kind of 30 minutes here. Thank you so much for joining us. And again, we will make a copy of this recording and the slide deck available afterwards. You can share that with your colleagues. So thank you so much for joining us today and taking the time to learn about Zeek MITRE ATT&CK, and Corelight. Vince, thanks again, and have a great day, everyone.
Thanks, everyone.